Hello everyone, welcome back to this physics video. Student, as today I am going to start over here. This is regarding to single movable pulley. Okay, so over here in my previous video, student, we have our discussion regarding to pulley, and in it I have done over there this single fixed pulley. So let us to have a recheck of this pulley is what. So we said over there, student, a grooved wheel which can rotate about its axle. Okay, so this grooved wheel we are going to call it is as pulley. Now this pulley, it was fixed in this structure. Okay, so here you can observe that this rectangular structure which I am having. Okay, so this rigid structure in which this pulley it is placed, or it surrounds the pulley. So this is said to be frame, or either we are going to call it is as a block. Okay, so whenever it is question to you what is block, so there you can reply that rigid structure that surrounds pulley. Okay, so it is said to be block. Okay, so over here, student, that this block it was attached to a fixed support. Okay, so here what was happening, that this was fixed with a fixed support. Okay, so therefore there we said that this pulley it can be of a different type. Okay, so it can have single fixed pulley, it can be single movable pulley, and it could be the combination for that can have single fix, sorry, that can have fix as well as movable pulleys. Okay, now over here, that what we did in our single fixed pulley, so important to note over here, it is only a single, and the second thing, it is fixed. Okay, so which pulley is said to be single fixed pulley? So for this, student, we must to remember the pulley in which this block, okay, so the block is fixed to this rigid support, and there is only single pulley in this block. Okay, so which pulley is single fixed pulley? That when there is single pulley in the block, and this block is rigid, supported by this rigid support which is fixed, it cannot move up and down. Okay, so therefore a rope is crossing over it. So one side of this rope there is load, and other side there is effort. So there we said that the right side this rope, it will tend to pull this load upward. Okay, so it is having tension in upward direction, while this side we are applying the force in downward, that is said to be our effort, and the rope tends to pull us in upward, so therefore tension is in upward. So one more thing which I told you, that I always try to show this one to this fixed point. Okay, so that fixed point whatever is there. Okay, now over here, student, its mechanical advantage it was 1. Okay, so therefore load equals to effort. It means to say that if I am having a load of 50 Newton, how much is that effort I will apply with the help of single fixed pulley? So this effort it will also be of 50 Newton. Okay, so that means what is the purpose of this single fixed pulley? So there is only the change in force direction. Okay, actually we were applying the effort in downward, and this load was going upward. Okay, now over there we also said in this case that velocity ratio is equal to 1, because as much there is the displacement of effort, so much is the displacement of load. So velocity ratio was 1 and efficiency was 100%. Okay, now this time I'm having that a single movable pulley. Now which pulley is said to be single movable? So student, according to that exam point of view, we must know how to draw the diagram. Second thing, how to show the tension in the string, and the third thing is there, where is that load, where is this effort applied. Okay, so important is there, we are getting that question regarding to this. So let us look over here. I'm having, this is the fixed support. Okay, it is the fixed support. Now what is over there? It is single movable. Okay, what is that? There is only single what it is moving. Okay, so therefore student, we are going to say that this pulley which will be used in this case, it is free to move up and down with the load. It is not now supported with this fixed support. Okay, it is not attached with this fixed support. You can understand it in this way. Okay, so let us look over here, there is this rope, so the one end of the rope, it is tied with this fixed support. You can note it down. Fixed support is this one. So the rope is tied with this one, and there the other end we are having over here that we will apply the effort, and here we are having pulley. It is this pulley. Okay, there is pulley and the frame of the pulley. So that block of the pulley. So here it is the block. Okay, and this load you will attach over here. Here is that load. You can directly attach that one as well, or you can show it with this T sign over there. So here it is the load. Okay, so student, you will check over here this block. This time it is not fixed with the this fixed support. Okay, it is with the load. So therefore, when we will apply the effort, okay, in upward, so what will happen? This load along with the pulley, it will also move. Okay, so therefore it is said to be movable. What in our previous case we said that block, it was fixed with the support. Okay, but over here this block, it is movable. It is attached with the load. Okay, so pulley which can move up and down with load. So this is movable pulley, and we are using only a single, so it is single movable pulley. Okay, now over here, to which side we can show the tension developed. Okay, so that tension developed, it is in upward direction to that fix. So fix is upward, so tension is in upward direction, student. Okay, so therefore how much is the mechanical advantage over here? So mechanical advantage, how do we write it? It is given by load to that effort. Okay, so just to check over here, student, as I'm having here, it is the two side of the string, and there it is pulley in it. Here is the pulley. Okay, so you will find that there is this load. So you will find over here this tension, the two side tension which is developed in the string, it is trying to lift up this load. Okay, so therefore load, how much is this over here? It is double of T, twice the tension is acting over here in upward. Okay, so they are trying to lift this load. And effort, if you will find over there effort, student, so effort is applied only on this single string. Okay, here is the effort. So this effort will be equal to as much there is the tension developed. So this effort is equal to tension. So thus I am having this mechanical advantage. It is equal to 2T by T. And finally I have this as mechanical advantage equal to 2. Okay, so how much is the mechanical advantage of single movable pulley? It is 2. Okay, now let us take over here, student, that what will be the velocity ratio of this. Okay, so velocity ratio. So for this, student, just to check that one, as I'm having, it is that fixed support, and the one end of this string, it is attached with this fixed support, while the other end is free, where you can apply the effort, and there is a single pulley. So with its block, we are going to attach this load. So this is that block. Okay, so over here, that a single line I'm going to show. So the load is at this point. Okay, now student, you will check over here for velocity ratio. What is that? Velocity of effort to that velocity of load. Okay, so we are taking over here that in same time as this load will up movement, so same time this effort will also move in upward. Okay, so that time I'm going to take over here, it is of 1 second. Okay, so what will be over there? Then I can write this one velocity ratio, it is displacement of effort to that displacement of load. Okay, already we have discuss, it is velocity ratio can also be written by this formula. Now check over here, student. Just to suppose that initially here it was the pulley. Initially this was the position of the pulley. Here it is the position of the pulley. Okay, it was having the load. Now this pulley has displaced up. Okay, so let us suppose it has displaced up by D. Okay, now the present situation of this pulley is going to be like this one. It is the present situation. Okay, so why it had happened? Because you have applied effort at this edge. Okay, so now just to look over here, when there is the D movement of this pulley in upward, so this load will move also the same distance D over there. And the string on the both side, there is one string which is to its left and the string which is to the right of this pulley. Okay, so both will move D distance. Okay, so D will be moved over here and D will be moved over here. Okay, so how much is the total distance which is moved? It is double of D. Okay, so therefore student, here displacement of effort, that it is how much is that string has moved. So this has moved double of D. And how much is that displacement of the load? It was only D. Okay, so thus velocity ratio, that it will be over here, that of 2D by D, and this is going to cancel. Velocity ratio is equal to 2. Okay, so we get that this second class sorry this that movable pulley is having its velocity ratio equal to 1. And we are known with one thing, that for what purpose we are using this then. So when mechanical advantage that is equal to 2, means to say greater than 1, so used for force multiplier. At once recall your previous those experiences regarding to the lever. So mechanical advantage greater than 1, it is used as force multiplier. Okay, so here you can check this student, that the effort is applied to this side. So tension, how will you show? Where you will use the load and where the effort will be shown. Okay, so this is important to note over here. Now let us check one more thing student over here, that if I'm having a load of 50 Newton, if I'm having a load of 50 Newton, so with the help of this movable pulley, how much is my effort? Okay, so as we are known over here, what I want to find out, how much is my effort, so that I can lift it up. So student, over there, mechanical advantage for this single movable pulley, it is 2. So therefore, as we are known that a load to the effort ratio, it is mechanical advantage. So I want to find over here effort, load and mechanical advantage is known to me. 50 Newton I want to apply, and over there 2 is the mechanical advantage. So it is 25 Newton. So how much is my effort? It is only of 25 Newton. Okay, so it is going to be as force multiplier. Okay, so thus this velocity ratio is 2, mechanical advantage is 2, and this is used for force multiplying. But now over here student, you should to remember one more thing, that here mechanical advantage and this velocity ratio will not be equal. Okay, it means that efficiency will not be 100%. Here effort we are, because mechanical advantage is given by load to the effort over here. And if there is the weight of this pulley, okay, so what will happen, that we are having over there that weight of the pulley and this load, so the total weight will increase over here, and this will be balanced by the tension which is in the string. Okay, so thus we have to apply more effort than the required load which we want to lift it up. Okay, so therefore what is happening over here, we have to apply more effort than the load, so this mechanical advantage will decrease. Okay, so this we will discuss at the last of the video. There will be a numerical for you, so from there it will be very much clear to you. Now look over here in the upward direction, but this is not that easiest way for us to pull it up. Okay, we will find it very hard to do this work. Okay, so what we will do, we will try to change the direction of effort. Okay, So to change the direction of this effort, what I should to use over here? If I will use a single fixed pulley, then effort can be applied in the downward direction. Okay, so let us to check it over here, student. Here that for making this for having convenient apply of effort. So this is single fixed pulley I am going to use. Single fixed pulley used with single movable pulley. And mechanical advantage comma velocity ratio will remain same. So over here important thing that we are going to learn कि जो एफर्ट था उसको कन्वीनियंटली आसानी से अप्लाई करने के लिए हम उसके डायरेक्शन को चेंज करने के लिए सिंगल फिक्स्ड पुली यूज़ करने जा रहे हैं और जो मैकेनिकल एडवांटेज और जो वेलोसिटी रेशियो होगा दैट विल नॉट चेंज, वो एज इट इज़ ही रहने वाला है. सो लेट अस टू चेक ओवर here I am having this is that a single that of fixed support is this one. Here is this single movable pulley. So this is over here single movable pulley on this string, and that load is attached with it. Here it is the load, and over here now this rope I am going to cross it over the single fixed pulley. So it is the support of this that block of the fixed pulley, and it is this fixed pulley. Okay, so now over here I will apply the effort. You will find that it will become easier for us to pull it in downward instead of lifting it up as we were having in the previous diagram. So in this case, student, you will find that tension in this one, tension in this one. Okay, so tension in this one. So here that mechanical advantage, it will remain same as 2. Okay, but it is when it is equal to 2. So when this pulley, it is weightless. Okay, so at that time we have mechanical advantage equal to 2, and that velocity ratio, so velocity ratio we are getting that it is also 2. Okay, so over here that of this system of pulley which we are looking over here, its mechanical advantage is 2, velocity ratio is 2. Okay, so if I will give this pulley it is A name, and this second pulley it is as B name. So what is the function of a pulley? A function. What is the function of a pulley? It is force multiplier. And what is the function of this P, that of B pulley? So this B pulley which is used over here, it changes the direction. Of applied force. Okay, so therefore this second pulley is used. Okay, so important to note this one. Now over here, student, if we are supposing that, just to consider this one, if I am going to have this is fixed support, here it is fixed support, and the one end of the pulley it is attached over here, and here there is I am having single pulley. Here it is a pulley on it. So this pulley is having the load. Okay, I'm having this one. Now over here, let us suppose there is this uh, end of this pulley, end of the this side of the rope. It is attached with the block of the second pulley. Here it is the block of the second pulley. So it is attached over here, and this is second that rope it is going under of it. Okay, so thus it is this is second pulley which I am having. Now if I will suppose that ये जो second rope है इसका जो ये end right side end है, now it is attached with the third, that block of the third pulley. Here it is the third pulley and it is block over here. ब्लॉक ये जो लाइन जैसी मैं शो कर रहा हूँ ये ब्लॉक को शो करने के लिए लगा रहा हूँ, ठीक है। इनिशियली आई टोल्ड यू ब्लॉक को आप इस तरह से शो कर लो या फिर आप इस तरह से फिर इसको शो कर सकते हो। ये क्या है, ब्लॉक के लिए रिप्रेजेंटेशन है। ब्लॉक क्या था, ये वो फ्रेम थी जिसके अंदर पुली होती है, ठीक है। सो ओवर हियर दिस वन इट इज द थर्ड पुली विच आई हैव कंसिडर्ड। नाउ द नेक्स्ट that to make this effort inconvenient, I'm using over here single fixed pulley. So therefore here I'm using single fixed pulley. This is that single fixed pulley. So just to check over here, सिंगल फिक्स पुली का जो ब्लॉक है वो फिक्स सपोर्ट के साथ अटैच किया गया, ठीक है। एंड दैट एफर्ट आई विल अप्लाई एट दिस एंड, ओके। सो स्टूडेंट ओवर हियर आई एम हैविंग हाउ मेनी दैट पुलीज, 1 2 3 and all are what, movable. When you will pull down this effort, जब आप effort से ये रोप नीचे की तरफ पुल करते हो, so this C, ये जो C है जो पुली, ये क्या करेगी, अपवर्ड मूव करेगी। C के साथ कौन लगी है, ये B अटैच है, तो ये क्या करेगी, B को ऊपर पुल करेगी। और B के साथ कौन अटैच कर रही है, A, तो ये क्या करेगी, A को ऊपर पुल करेगी। और जो A है वो किसको पुल करेगा, लोड को, ठीक है। सो यू विल फाइंड दैट दीज आर मूवेबल पुली, ठीक है। सारी की सारी कैसे हमारे पास ये मूवेबल पुली है, ठीक है। तो इस सिस्टम का हमारे पास मैकेनिकल एडवांटेज और वेलोसिटी रेशियो क्या होगा, ठीक है। सो देयरफॉर व्हेन वी हैव एन मूवेबल, एन आई एम राइटिंग ओवर हेयर एन, एन का मतलब हो गया आपके पास 3 भी हो सकती हैं, 4 भी हो सकती हैं, 5 भी हो सकती हैं। सो दीज आर एन, okay. So when we have n movable pulleys and one fixed pulley, then mechanical advantage. So mechanical advantage, it is given by 2 की power n, okay. What is over there, it will be 2 की power n, and velocity ratio it will be 2 की power n, okay. This is the shortcut formula for you to learn. Suppose that I am having 3 pulleys, okay. So what will be the mechanical advantage of this system then, it is over here 2 की power 3, means to say it is 8. And what will be the velocity ratio for this one, it is 2 की power 8, okay. So if all the pulleys are weightless, then mechanical advantage and velocity ratios are equal. What if all are not same, then mechanical advantage will be smaller than that of velocity ratio, okay. So one important news regarding to that, velocity ratio for given system will not change, गिवन सिस्टम और गिवन सेट, ठीक है। तो जो हमारे पास गिवन सेट है उसके लिए क्या चीज़ चेंज नहीं करती, वेलोसिटी रेशियो चेंज नहीं करता, बट मैकेनिकल एडवांटेज कैन चेंज ड्यू टू द चेंज इन, ड्यू टू द वेट ऑफ स्ट्रिंग और वेट ऑफ पुली, ठीक है। तो हमारे पास जो मैकेनिकल एडवांटेज है वो किसकी वजह से चेंज कर सकता है, जो वेट है उस पुली और स्ट्रिंग की वजह से, ठीक है। तो वो चेंज हो सकता है। तो इसका मतलब हुआ हमारे पास दिस वेलोसिटी रेशियो will not be equal to mechanical advantage, and even though we are known this one velocity ratio, it is greater than mechanical advantage, और इट इज़ इक्वल टू मैकेनिकल एडवांटेज। इक्वल होगा आइडियल केस में, ग्रेटर होगा जब वहाँ पर ये जो हमने यूज़ किए हैं कंपोनेंट्स वो परफेक्टली वेटलेस नहीं होते हैं, ओके। सो दिस इज़ दैट वी आर हैविंग, okay. Look into this example, student. Here we are having single movable pulley, so this load is attached with that pulley, and this effort is applied on the free end of this string, okay. So tension developed, it is shown with the arrows, okay. Now over here what is given to us, that the weight of the pulley is 5 Newton. Over here what is happening, this weight is having its that pulley is having its weight 5 Newton, and that load which is attached to it, it is of 50 Newton. So question is there, how much is the mechanical advantage and effort? So student, over here you can't say that mechanical advantage is 2. Why you can't say this one? Because there is uh, this pulley, they are not weightless. Okay, so the reason is there. So mechanical advantage is equal to 2. You can't say that. That is not equal to 2. Okay, but velocity ratio will be 2. It is granted over there. For given set, velocity ratio is not going to depend on that load. Okay, so it is 2, but this mechanical advantage is not 2 over here. So we have to determine it, how much is this. Okay, so for this student, just to check it over here, as I'm having this single movable pulley, so its weight is given as W, and that load which is attached with it, it is that L. Okay, so due to of this total, जो हमारे पास टोटल वेट कितना बन गया, अब पुली और लोड दोनों को ऐड करके टोटल वेट बना, तो इनकी वजह से क्या हो जाता है, स्ट्रिंग में टेंशन डेवलप होती है, ठीक है। सो देयरफॉर दिस टेंशन इट इज टी, दिस इज टी, तो दोनों टेंशन अपवर्ड में है, तो दो टेंशन ऊपर की तरफ अप्लाई होकर के क्या करती हैं, ये जो टोटल वेट जो नीचे की तरफ है उसको बैलेंस करता है, उसके बराबर हो जाता है, उनके सम के बराबर। तो इसलिए मैंने लिखा वेट प्लस लोड इज इक्वल टू डबल ऑफ टी, ठीक है। दो टेंशन मिल करके जो टोटल वेट है उसको बैलेंस कर रही है। सो एंड नेक्स्ट थिंग, हमारे पास ये जो एफर्ट था वो ओनली इस टेंशन के, जो सिंगल स्ट्रिंग के अंदर टेंशन है उसके बराबर डेवलप किया जा रहा है, ठीक है। सो दस आई गेट ओवर हेयर दिस एफर्ट इट इज इक्वल टू टी। तो स्टूडेंट, टी की जगह मुझे ई रखना है इस वाले जो इक्वेशन में, ठीक है। सो देयरफॉर आई गेट ओवर हेयर डब्ल्यू प्लस एल इज इक्वल टू डबल ऑफ ई, और ई यहाँ से 2 डिवाइड में चला जाएगा तो W प्लस एल अपॉन में 2 हो जाएगा, ठीक है। तो W की वैल्यू यानी कि वेट ऑफ द पुली 5 न्यूटन था क्वेश्चन में, 50 न्यूटन लोड का वेट है, और हमारे पास डिवाइडेड बाय 2, तो इसलिए कितना एफर्ट मैंने लगाया, इट इज़ 27.5 न्यूटन। दिस इज दैट एफर्ट विच आई हैव अप्लाइड, ठीक है। एंड इफ दिस इज द एफर्ट देन हाउ मच इज माई मैकेनिकल एडवांटेज। तो मैकेनिकल एडवांटेज मेरे पास स्टूडेंट क्या हो गया, लोड टू द एफर्ट। तो लोड, कितना लोड मैं उठाने जा रहा था, दैट वाज ओनली 50 न्यूटन, ठीक है। तो 50 न्यूटन का लोड था और एफर्ट मैंने 27.5 अप्लाई की, तो इसलिए मैकेनिकल एडवांटेज 1.81 बना, ठीक है। बट स्टूडेंट जस्ट टू रिमेंबर, इफ दिस विल नॉट बी इंक्लूडेड, इफ इट इज सेड दैट देयर इज वेटलेस, वेट ऑफ द पुली इज 0, okay, so what will happen here, what thing is there, this W will be 0, so L will be equal to double of T, okay. So therefore this effort will be equal to 25 Newton then, okay. So it is exactly, we are going to say that in case when weight is equal to 0 of this pulley, so mechanical advantage will be 2. Either we can have that mechanical advantage will be less than 2, okay. So therefore on the behalf of this, efficiency will not be 100% for this single movable pulley. So thank you for watching.